This particular project was about forming thin metal aluminum sheets through incremental forming, robotic forming. You can think of it as a robot with sort of the needle at the end is going many, many times along the same axis until it pushes the metal through. The result are kind of nice-looking patterns, like you see here, which give the metal stiffness.
It's very clever if you start to combine different methods and different tools together to be, on one hand, sophisticated and also to get some beauty.
Look at a public space and figuring out, just with a few prompts, how things will look like if you replace, this is just like this space, and you put a couple of keywords, standing desks, co-working space, green, etc., and it just populates things like that. And again, project done in less than a month with no AI knowledge before.
Dobrý večer, dámy a pánové, já vás tady vítám za Galerii Architektury a nadaci české architektury na diskuzním večeru na téma AI-tektura. A než předám slovo šéfredaktorovi časopisu Era 21 Filipu Landovi, tak bych přepla do angličtiny, protože tady máme i anglicky hovořící. So good evening, ladies and gentlemen. Let me welcome you here at the field of Gallery of Architecture and welcome you in behalf of the Foundation of Czech Architecture. Today we will be having the discussion evening on the topic of AI-tektura, and I would like to give the floor to Filip Landa, who will be the moderator of today's event. Have a great evening.
Okay, I will start in Czech and then I will switch into English. Taky vás všechny vítám a my jsme tenhle večer zorganizovali hlavně z důvodu toho, že jsme nedávno vydali číslo našeho časopisu, který si můžete rozebrat a vzít domů. A to číslo jsme nazvali jako AI-tektura, čili architektura a umělá inteligence. To číslo jsme sestavili dohromady především, a těm dvěma patří především můj dík za to, že jsme to číslo vůbec byli schopni jakoby sestavit, a to je Šota Cikolia a Jiří Vítek, kteří nám pomohli právě s tím obsahem, protože oni jsou opravdu odborníci, na rozdíl ode mě, na tyhle ty věci. And I am happy to welcome here also Angelos Chronis from Vienna, from Infrared City platform. I think it will be a very interesting presentation. And also Jan Pernecký, architect, who is also dealing with AI in architecture. So, and we will start with short presentations, and Shota now will show you something about our goals of our issue and about the topic of AI. So, Shota, it's yours.
Thank you. Thanks a lot. Let me start. Okay, thanks. So, that's not what I see here. I think, like, if I double it, I think it will be okay. Sorry.
Close this one. And then here, double it.
Okay, great. That's what I wanted to show you. Okay. So, first of all, I was a bit unsure what to show. I understood that I have to show something for 10 minutes, 15 minutes on the topic of AI. My starting point is I right now work on two platforms. One is Studio Architecture 3 at Formou, where I teach together with Imre Vaško, whom I'm happy to see here. And another is my personal architecture practice, Kolark, where I cooperate with a couple of colleagues. Within our practice, we mostly deal with architectural, small-scale architectural projects, renovations. We try to integrate different computational tools in our work, but I don't think we ever used AI in our design process in a really narrow sense. I'm not talking about using some AI assistants. Within our academic practice together with IMRO, we deal with computational tools perhaps even more, yet AI was always maybe to the side of it. When there was this kind of mainstream popularity of AI a couple of 2 years ago maybe, with this softwares like Midjourney and DALL-E and Stable Diffusion published, we dealt with it a little bit more, but it's not the focus of our studio. So I actually at the beginning was not quite sure why I was approached to do this. Then I realized it's precisely the reason that I don't deal with AI. And therefore, I decided to build this presentation as sort of my personal encounter with AI, which maybe could be giving clues why together with EG, we approached the people we approached. So I'm not going to start with some science fiction movie which involves AI. I would really go to the point, to the architecture. So I was looking back into my memory. First thing was in 2016. We cooperated with my former classmate Giulio Brugnaro, who at that time was doing PhD in Bartlett, and we asked him to come to Umprum, to our school, where he did work. We prepared a workshop basing on mainly his Bartlett research on robotic carving. The workshop was called Emergent Wood Formation, and we covered different things, but his robotic carving research is mainly the AI-related event. Within his research, Giulio thought how to integrate the artisan knowledge, artisans carving from wood, to the machines. So he didn't use word AI, he used much more precise term for this, machine learning, because that was precisely what it was about. Artisans were carving using chisel, which in that case included a load cell, which was collecting data on how much they press into the wood, how much they feel the resistance of the wood. This data was compared to the results of their work, to the 3D scans and other methods of digitizing the results of their work. And through neural networks, some sort of nonlinear relation between the load, the force of the artisan and the result was found by the computer. And this sort of relation was integrated into the robotic tool which was carving it further. The idea was that robots up till then were mostly using kind of very simple linear processes like 3D printing or CNC milling, where you don't really care about the forces involved, or you do, but to much lesser extent, while with carving you need that sort of feel. And the idea was that machine learning could help us to create an application of that very manual process to the machine logic of the robotic arm. So that was actually my first impression, what AI can help us with. The machine learning, I think the word machine learning describes it much better than the word artificial intelligence. And actually, my next encounter was pretty soon, the same year, when we, with our students, visited the exhibition Complex Modeling at CITA in Copenhagen. And among other very interesting things, encountered the project A Bridge Too Far by Paul Nicholas and a lot of other people. Actually sort of enforced me in that that's the way AI can help us. This particular project was about forming thin metal aluminum sheets through incremental forming, robotic forming. You can think of it as robot with sort of the needle at the end is going many, many times along the same axis until it pushes the metal through. The result are kind of nice-looking patterns like you see here, which give the metal stiffness. Again, this is non-linear process. It's much more complicated on the material level than if you mill something, because the metal, instead of getting out, is being stretched, is being deformed. There is plastic deformation, there is up to a point elastic deformation, and you can't just decide I am going to put the robotic part this way and that's what I'm going to get. There is sort of more complicated relationship. And again, the AI, the machine learning in this case was used, neural networks were used to compare the path of the robot, the loads within the robotic tool, and the 3D scans of the result to be able to predict further tests, further prototypes, and help us to understand how this system of a material with its complex behavior and a fabrication tool with its relatively complex behavior as well, how they work together. Something maybe less exciting on the first point of view, but something which would be very difficult to do in any other way. That's 2016. By that time, I had very little idea how neural works actually work. I mean, I still don't, but at that time I didn't even know why they called neural networks. That was about to change when I visited a conference in Poland where I met Mateusz Wojcicki, who I think up to a point cooperated also on that program. There he had a very interesting lecture on his newly published tool called OWL, which was a plugin for Grasshopper. I don't know if many of you use Grasshopper, which is by itself an extension, a plugin for Rhino. OWL, the plugin, used to allowed you to use tensors within Grasshopper. Basically, a mathematical tool, tensors, a mathematical tool, which allows you to create simple neural networks, to create simple machine learning processes. And that is very visual. By the time I really loved using Grasshopper, so I thought I'm going to give it a try. And later it ended up with our own workshop, which we called backpropagation, not because backpropagation was particularly relevant, but because it was a cool name. We later cooperated a little bit also with Mateusz, who distantly gave us a lot of input. This time, the use of AI was probably much more superficial. Basically, again, machine learning process involved is about putting some inputs, putting some outputs, and learning some logic, nonlinear logic behind them. In these cases, we used this logic to create 2D gradients between different geometrical, maybe architectural shapes, and to see some kind of combination, some kind of collages, some kind of gradients in between. So students were creating different shapes, which remind them maybe some architectural spaces. In that case, we were also considering later ending up designing concert halls, things like that, acoustic spaces, acoustic halls, and running this tool, allowing students to create sort of different combinations, different gradients, something which theoretically would be harder to come up by themselves. The clear advantage of doing it this way was also that you can very fastly, very rapidly get 1,000 variations, run them through some optimization mechanism, and see which variations worth your attention and which don't. Like in this case, in the case of this image, you have, I don't know how many, but let's say a couple of hundreds of shapes. You run it through some analysis tool, and the analysis tool would tell you that these bits are maybe somehow interesting for some reason, and these bits are making no sense at all. Then you concentrate on these bits and you can work further. This was, for me, kind of more direct sort of approach related to architecture, or directly imaginable, but still there was sort of the connection I could have seen between the first projects and this one. And then we had a break. I'm not saying the whole industry had a break, but us in our studio did. I couldn't find anything before COVID, I think, and then I found that we've been to a lecture at CTU by Mateas del Campo. We didn't have him for a workshop, and we weren't involved in any kind of more meaningful way, but we've seen this really exciting lecture which showed us completely different side of use of neural networks in architecture. Mateas del Campo called that at the time machine hallucinations. And within the lecture, although the results are completely different than what you've seen before, we've seen that there is some similarity in the logic to some extent. Of course, the tools were much more sophisticated, but again, I would say that was analysis of some input, some library of input. In that case, the library was images, so much more complicated library than what we had with these boxes. The result was some sort of deconstruction and reconstruction of that images in a way that much more powerful softwares like Midjourney and DALL-E and Stable Diffusion and others would make it mainstream in just a couple of years. Then obviously COVID came, but it also had one positive side to it. I mean, that sounds a bit cynical, so maybe. There was an opportunity to explore the advantages of online learning. We had this school, as all the other schools were closed, of course, we were teaching online. And then we realized that then if we're teaching online, we can approach a lot of interesting people who otherwise would not come to Prague. We did Umprum Architecture lecture series, and we invited lots of people, among which one of them was Neil Leach. The lectures were covering completely different topics. So Neil Leach himself, he had his book about to come out at that time, Architecture in the Age of Artificial Intelligence. Now, actually, the second edition comes out, I think, maybe it already came out. I think it's supposed to come out the end of this year. So I really recommend it to everybody. And the lecture was really important for me because it was first time I seen a sort of overview of what happened, explained in a very systematic yet relatively simple way, with emphasis of what kind of is used by architects within, of course, within the sort of filter of Neil Leach, what he finds particularly relevant or what he finds promising. And then that's 2021, and 2022 was big revolution. Everybody started doing these very strange images on my social networks. I considered leaving social networks because of that. But it was sort of something which was impossible to completely avoid. Midjourney and DALL-E, of course, are commercial programs, and we thought we would at least wait for something open source which we can look inside and try to control in some way to come out before we will deal with it at all. So we waited a little bit for Stable Diffusion. But then we said, okay, if we are dealing with computation so much in our studio, we can't completely avoid it. We had a semester concerned with just playing with it, to be honest. I remember there was, I don't know, many years ago in high school, I was reading some popular book by Feynman, and he was, in his memories, saying that when he encountered first computers in late 40s, he thought he would just try putting different numbers and calculate it and see what comes out, and it was so exciting. It would take all his time, and I couldn't really understand what's so fun about calculating what's 351 is times 352. But then we did kind of the same things. Looking back at it, I don't quite see what's that exciting about trying different prompts and seeing the results. I think it's not much more. It wasn't much more meaningful than Feynman's explorations, but it was, I guess, sort of part of that year. So we did several projects where students were kind of just playing around what these tools allow. Is it possible to go into 2D? Are plans making any sense at all? Are sections making any sense at all? Should we use AI as I don't know, a tool for fast sketches and then start drawing it, start making physical models out of it? I still don't have answer to any of those questions. But some projects were created, some projects I even liked. But I can't say that this workflow was something I'm too convinced about. Another thing which happened was we cooperated with another studio, Studio Halada Bradnyansky from Academy of Arts in Bratislava, who had exactly the same topic, exactly the same approach. These tools are out there, let's try them. However, they were much more patient about it and tried to force students in some sort of framework so the results are comparable and somehow possible to kind of present in a very linear way. That was something that at the time I personally found not too useful. I thought like that's literally a sandbox, a playground, then we should play. But when I seen the results, I was quite interested in how they did it. I advise everybody, if you have ERA magazine, there is an article by Benio Bradnyansky about that particular semester and about his particular experience. That's, I think, quite interesting, different side to it. And if nothing else, I think this comparison was quite useful for myself. I'm about to end my presentation, so last encounter was this approach from Philip, and I thought if that's not the best chance to kind of finally learn something new about it, then I don't know what would be. So that's, you know, the best way you learn about something is you write about something. And I'm really happy to have, to be able to cooperate with UTV-Tech and to approach great authors, theorists, economists, philosophers, all those people which have agreed to participate in that edition of the magazine. So thank you.
Okay. So thank you so much for having me here. It's a really pleasure. And yeah, my presentation is a little bit different, but it has kind of similar points. And I will show you how our journey, about 10 years to developing these tools and having fun with digital computation design, was like this, like the introduction, why we are actually doing this. It's maybe about curiosity. Because, you know, as architects, we have a lot of troubles to deal with archetypes, to deal with something that was before, and we don't really understand why it's that. And now we have really great opportunity to maybe make a new approach, to maybe have new understanding of our world, and it should give us sense how the new architecture could be, because we also forcing a lot of new issues, and the city was like this. It was mostly, you know, planned by top-down thinking that, okay, some master draw the plan, say the city, but the problem was that we didn't have enough information to do such a complex thing like a city. And digital tools can help us to better understand what is happening. And it's exactly like I call this page Egg or Chicken. Maybe it's not proper title, but it's very crucial. Because somehow we're using our thinking based on history. You know, we use this kind of form, elements in the city based on ancient ideas, like the castle or Renaissance. But if we also use AI to get this result, maybe it's nonsense. Maybe we should think about the concept. Maybe we should think about the rules We should think about what actually are the essence of our design. And that can bring us into the new solution, which is very different. And there are a lot of troubles if you use AI badly, let's say. So in our approach, we set up methodology that at the beginning, you should really understand the problem and the essence of the problem. Then you build, we can call it a parametric model or any kind of, let's say, I call it vehicle, because you take the rules, you put an engine, let's say, and then you generate the answers, which we call proto-architecture. That you see, okay, I'm closer to my solution or not, and this is kind of loop that you apply this proto-architecture onto the site, and you see, okay, it's working for me or not. And digital tools can really help us to open the design pool and not wasting time with hand modeling or drawing or something like that. And the thing is that the model could be very informed. And we apply this in urban strategy, which I call successive palimpsests, because in nature's successive processes, it's like the forest is growing, which is not just one day, you know. There are so many small plants, small kind of organisms which grows, then you have bushes, then you have trees, and then it's growing into the state which we call climax. And in the same time, I like palimpsest idea that there is no tabula rasa. When we are going into any kind of site, there is all informations already. So it's not necessary to start from scratch. You can start with the data which are already there. And it's open to everyone. You know, you can go to any kind of city and you can download all the data in the minutes. You know, you can have all this information, and it's more about how you translate this information into the, let's say, what you are looking for, to the essence, to the kind of basic ideas. And from this, you can start to analyze and interpret the data into the parametric model. And we did this kind of experiment with the Brno, because you know Brno. So it's a great example. There is a south part of the Brno which no one knows because it's abandoned somehow. It's separated by the rails. And with the students, we start to analyze the city, and we realize, okay, there are some train stations which are not used as a public transport. So if we add them into the public transport system, the city could look very differently, which is very easily achievable. And let's say computation design can help us to understand what is happening. But for sure, if you have a short time, you can make a simple project in minutes, combining parametric design with the stable diffusion. And so we play with this a lot, and then we really have been lost in stable diffusion exploration to get a lot of images. We apply them so much, but you know, I'm not academic like the Shota, so I'm simple man. I like pictures. But the thing is, when you start to curate this in proper way, so we started with this box, which is prompt still successive palimpsest, and then you explore this into the combining different pictures, different models, into the something what you like. Because the problem with the stable diffusion was, if you apply that into the urban design, you always get a Zaha or something similar. So then, in clever way, you are able to go where you want. So that was it. And then you are able to control, you know, courtyard situation, roof situation. So it's not necessary that you are really lost. You can really curate this in proper way. And yes. And then, you know, we applied the same situation what we did with Daniel in 2021. with the Stable Diffusion model 2024, it takes minutes, like seconds. And to also get this animation now, instead of 1 week, it's 1 minute, 2 minutes. Yeah, in 10 minutes, let's say. Which is amazing because you can, play with this, you can stop it and go further. Your design tool, like design pool, is really open. And if you like Futurama, now you are able to make a, Tirana. Because I was teaching like 2 weeks ago in Tirana how to use these AI tools with the really basic students. So you can also have fun. It's not just be serious, right? But what is really surprising for me, how fast this go, because my son was idea, okay, let's make a game, and I have idea about a game character like eagle, and it was surprisingly like in, let's say, 10 minutes from the picture, we had a 3D model, which is good if you have eagle. And it's really bad if you're trying to get architecture. But it's yesterday, so tomorrow it will be different. So to conclude, I mean, it's very clever if you start to combine different methods and different tools together to be, on one hand, sophisticated, and also to get some beauty into the architecture. So thank you. We will change the computers.
Okay, thanks to Jiří. And the third one will be Angelos. I think it will be also a completely different presentation because the platform in City is example how to use AI in practice, in architecture or urban practice. For me it was very interesting. We invited Angelos because in the issue of Era 21 magazine you can read the interview with Oana Hout, who is a colleague of Angelos. She's working and teaching in Barcelona, but Angelos came from Vienna, and for me it was really interesting interview with Oana. So now I'm looking forward to your presentation.
Okay, well, thank you for having me. Apologies that Oana couldn't make it. I'm replacing her because she couldn't really travel. She has a little one, so she has to stay with her. I'm Angelos Kronis. I am one of the co-founders of Infrared City, together with Oana, Christos, and Theodore. And I'll start by saying, probably I'm a failed architect. That's how I normally present myself. I never did really manage to do real architecture like the rest, so I'll have to bore you with probably more technical stuff. That's what I've been doing mostly. I'm sorry, this is a little bit like annoying. So yeah, I'd like to ask, first of all, a question. Who is an architect here? So I know who I'm talking to. I'm also an architect, by the way, yeah? And who is a computational designer? Okay, cool. So now I know how many slides I have to skip, because I somehow got excited and I put about 100 slides in this presentation, so I'll just have to skip most of them. What I do is, so as I said, I'm co-founder of Infrared City. I'm also teaching at Barcelona. I'm a co-director of the Master in AI for Architecture and the Built Environment in IAC, Institute of Advanced Architecture of Catalonia, and I'm also advising the Austrian Institute of Technology in Vienna on what they do with the City Intelligence Lab, which was what I was building the last 5 years. So, and I'll try to connect my lecture to the reason why I do most of the work that I've been doing. I've been working with AI models, and I've been teaching AI models for about 15 years now with architects and planners. That's why I normally call myself also an AI boomer. So, when the whole sort of hype started, I was like, what the hell is going on? But at the same time, I also have the sort of FOMO that everybody else has, because it goes really so fast. But I'd like to go back a little bit to why, and I'm going to apologize in advance for making it a little bit eerie. But yeah, we have to remember, you know, the sort of like effect of what we do. So I'll start with climate change, unfortunately, and you know, it's very easy today to convince, you know, about this other sort of like fear. You know, it's the AI fear that's going to take our jobs, but it's also the fear of us being consumed by the mess we created. So that's the sort of like the numbers. 2023 was one of the worst years. I come from Greece. I think that's obvious from my accent, but that was also a sort of a, you know, what I was using. The first images I used to pitch Infrared City were these. In one summer, in one actually month in 2023, we lost 2% of our land in wildfires and 5% of our GDP in floods. So, you know, the situation is pretty bad, and we have to remind ourselves that as architects we have an, you know, sort of like also a responsibility of that. We live in cities, 75%, 70% of us, doesn't matter, will live in cities by 2050. Autodesk says we have to build 13,000 buildings per day by then, which is quite a lot. And then buildings are still sort of like the larger contributors to climate change. So like almost 40% of carbon emissions come from buildings, not from cars. I know we blame the cars all the time, but we here are more responsible than the automotive industry. We live in cities, 2% of the land, but 80% of the energy of the world is cities. And I'd like to stop at this picture because I think you probably all know this is London, right? You probably recognize that building on the left. This is what parametric architecture can also sort of like make possible, which is the walkie-talkie from Raphael Vignoli, or the scorchy-talkie, as it was named after it started burning cars in London because of its parabolic shape. So it was concentrating the sun rays and was burning these quite expensive cars. So they had to actually do something about the building. They had to put a filter in front, and very costly lawsuit. It would be okay if Raphael Vignoli did this only once, but he did it twice. He also did it in Vegas, where he built the Dara Hotel, and the employees of the pool area of the Vegas hotel, they would call it the death ray because it would come at a specific time of the day and would actually have like first-degree burns on people. So, you know, it starts getting a little bit like horrible when we, you know, when we actually have such a bad effect with our architecture. So coming back to AI then, and that's why what I'm trying to talk about here is like, how can we use AI to make architecture more sustainable, more responsible, more livable? And I'm gonna give you a sort of like random list of things that I've been working on, or that like, there are three different sort of like channels to that. IAC, the work of our students. We've been teaching AI in IAC for quite some years now, and there's some student work here, so I'm gonna say this is their work, not my work. The work that we've done in AIT at the lab, as well as Infrared City, which is essentially a spin-off from the lab, a spin-off from AIT, which is the company that we currently have. So I'm gonna start with a very brief history of computational design. Does anybody recognize this? I think probably not, right? Like this is probably, you know, prehistoric by now. It's when computers parametric design kind of like started. This is generative components by Bentley. We can call it the mother or the father or whatever of Grasshopper. So 15 years ago we had this. It was a terrible interface. Today we have this Grasshopper spaghetti that you've probably seen. I mean, or from your students, from your colleagues, that can do crazy things. And for me, what is also even more interesting is this sort of image. This is a connection of Ecotect back in 2006. I'm missing decades. When I started working with sort of like integrating performance, climate performance for buildings, this was a connection of Ecotect, which was the only climate simulation tool for architecture that you could connect like a sort of arbitrary surface and do a solar radiation simulation of it. This took me a week to just connect one software to the other, and it would never work. So, 15 years forward, we've got, we go to Food for Rhino, which is what Grasshopper geeks do, and we just download our flavor of climate simulation or structural simulation. We can have like whatever tool we want connected to Grasshopper, and today we're wondering like, AI, what will it do to this sort of like tool chain that the architect has? And I think that I'll start with trying to decipher what is AI. So I'm not sure if anybody has already like done already a few courses on AI, but I'm going to apologize because this is a very simple explanation of what AI is. And I'm going to start with artificial neural networks. They were talked about a little bit before. And they're quite simple, actually. They're not that complicated. I know they sound very complicated, but they're not that much. This is an actual neuron of a human brain. I didn't have anything to do with this. This is downloaded from the internet. I didn't dissect anybody. And this is kind of like the diagram of an actual human neuron, right? And that is the artificial neuron. Essentially, it does the exact same thing. It has a bunch of signals coming in, a sort of activation function, and then outputs a certain other signal. And neural networks are nothing more complicated than a bunch of those connected together in a way that they can learn patterns, they can recognize things. Like, for example, the simplest thing, recognizing handwriting, like just a number written on a sort of like envelope, which is, a postcode, and just training a network to connect these sort of like a series of neurons to just recognize things. But you can do really complicated things like, start watching people and cars and recognize terrorists or whatever you have to recognize on the public domain, or going to architecture, starting with a student project. This is Luyan Chang, one of the first projects we did in recent years in IAC, where she's looking at street view images and she's trying to understand essentially what a street is, just looking at the image from the street view. So detecting how many people, bicycles, or furniture exist there, how much road, how much sky, and with that simple sort of like, image segmentation and models, she can actually create accurate representations of what types of roads we have and actually create an accurate map of Barcelona's main street type. So, just looking at the street view, you can get enough information to understand what the street is like. And the same principle we kind of applied in Bike Map and other projects from a few students in IAC, where you're looking at streets and you're trying to figure out how safe they are for biking. But it's not just about like figuring out, how to go from point A to point B through a bike path, but it's actually trying to figure out where trees are, where lighting fixtures are, where sort of like, safety problems are. Because, I think here you have the same problem we have in Vienna. If it rains a bit and you try to cycle through the tram network, you know what happens, right? So that's sort of one of the things that we were trying to understand. So then you can create accurate maps of how well lit a street is, of how safe it is in terms of like, this sort of like obstacles, how vegetation is sort of like present, and how well paved, or if it's a cobblestone, because you don't want to cycle through cobblestone, or a better sort of like pavement. And with that sort of thing, you can actually choose a path that is safer or more sort of like useful to you. And again, we have no clue about the city. We're just looking at street view images, and we can understand all these features just by looking at images. So it's about us understanding things in the urban environment without really needing the data. And going into a little bit like of a concept that is fundamental for artificial intelligence and for machine learning, but also sort of like a little bit difficult to grasp, which is this idea of dimensionality reduction. How do you look at like a multitude of dimensions and kind of like reduce them to enough that you can understand certain patterns? This is a fantastic book, probably for your kids or also for yourselves, which is sort of like explaining multiple dimensions, in a very nice and sort of accessible way. Our human brain does that as well, so it kind of like takes multitude of signals and converts them to very, very simple sort of like representations so that we can actually operate like, I'm currently probably seeing every one of your faces, but I'm only going to focus on one or two of them because I have to speak to you. So we do the same with data. Very good example, at least 15 years ago from UCL. This is space syntax, analyzing how well integrated every street is with every other. So you can see Oxford Street being like super red there because it's one of the most integrated streets. And then you just take, these sort of like analysis of how integrated streets are, plot it, and then you can, reduce it to only 2 dimensions and plot multiple cities around the world. And you can very quickly see that they have a specific characteristics of how streets are integrated and they sort of like group together, like North American cities, Middle Eastern cities, etc. So there's something intrinsic to a city network, to a street network, that tells you where this city is. Same thing for floor plans. You can look at, for example, how visible, this is a visibility graph analysis, typical space syntax analysis, that you can see how quickly, how much you can see from a specific point in the floor plan. And when you plot these in 2 dimensions, you can still sort of like plot essentially floor plans in history of architecture. So you can know where roughly a floor plan was designed by just looking at the numbers of how well connected visibly this is. Running a little bit like quickly because we don't have that much time. We apply the same concepts in things like identifying voids in cities, so figuring out the distance of every void in a city with schools, churches, hospitals, and all other amenities, and identifying clusters of or opportunities for development. Where should we put a new school, or where should we put a new sort of like park, and how would that affect the distribution of these amenities along the cities? And using, again, this idea of dimensionality reduction and machine learning, making an informed decision of where the school needs to be done. Again, these are student projects. They are normally done within 1 or 2 months, and the students have no idea about AI before. So that sort of like is a really good example of how fast we're moving. Same thing for streets. You're looking at open data in Vienna. You are identifying different sort of like water features or green features or other features like that, and you can very quickly categorize streets in relation to how much, what sort of resilience, sort of like measures they need to adapt for the climate change, and you can create different types of streets and very quickly create policy for the city using, again, data, dimensionality reduction, helping the city make decisions with data. What about sort of portions of the city that are not planned? The informal sort of like parts, you can still use AI, like the pix-to-pix models that we were talking about before, to just very quickly create maps where they don't exist, and then distribute amenities and figure out how you can actually develop, unplanned parts of the cities. How much time do I still have? Maybe 10 minutes. All right, brace yourselves. So generative AI. We talked, I think you talked about pix-to-pix models, like these are like generative models. This is what goes behind the sort of mid-journeys. It's essentially just a bunch of networks that just generate images and then categorize them, of whether they are good or bad. There's a discriminator and a generator network. I'm not going to go into the details of how this is happening, but you probably have seen all of these sort of things that you can take, a photograph and you say, I'm going to now make it a Monet painting, or I'm going to make it a, I'm going to take a zebra and make it into a horse, or I'm going to make a horse into a zebra, right? And I'm going to make a video of a horse turned into a zebra. Or I'm going to take myself and I'm going to make myself look like my dad, or like, this face up you probably have used at some point to turn into a different gender or whatever. So we use the exact same model, but for simulation. So what you see on the left is an actual solar radiation simulation, yearly solar radiation simulation of a part of a city. What you see on the right is our simulation prediction. One takes half an hour and the other is instant. So we do that by using the same type of models to predict simulations rather than random. This all happened at AIT, at the City Intelligence Lab, which as I was working at, I kind of like built it before Infrared City. And the idea of the City Intelligence Lab is to bring together all the different sort of like types of analysis and expertise to help decision making in urban planning. And there's a few things that we've done there. I'm going to skip through some of these things because, skim through some of these things because they're interesting, like decoding spaces, toolbox. I don't know if you've used that, or if you're using Grasshopper for urban planning. It's probably the most common sort of like tool out there. It can very quickly generate street networks. You have a plot of land and you can generate a street network, populate different typologies, essentially create whole master plans with the click of a few buttons, just crunch numbers in and it just generates form. Or at the end of the day, just sketch urban form. This is an amazing project by Mohammed Rayed. He's now at Henning Larsen. I was an intern at the CIL, and he can essentially, he's sketching things, he's putting sort of like shapes in, and it populates different typologies, different sort of like street networks with a few parameters, roofs, no roofs, types of buildings, etc. So it's all about generating urban form without ever you needing to model it, this sort of like idea that you were talking about before. It's also about analyzing it, like putting a point in a city and figuring out what you can reach through all of the street networks, transport networks, buses, bike paths, etc. And essentially creating isochrones or sort of like analytical tools that help you, figure out where to put the next train stop, or where to put the next tram stop, and how to make essentially circulation better, or do things like, this is also what we did at the CIL, rain fall-off simulation. I think this couldn't be more relevant now after what happened in Spain, and still happens today, I think in Malaga. This sort of like how rain falls through the city, what sort of areas will it go to, what buildings have basements that will need sort of like, resilience measures, etc. So this kind of simulation, what you see here, and I think that was touched upon before, computationally very intensive, takes at least a day to run just one scenario. And that was the reason why we built infrared, right? So essentially infrared takes AI and makes the simulations sort of like instant. So we take something that takes maybe 3 days to run, and we go directly to the result in less than a second. And that's what infrared is about. So, this is what I talked about before. One is a simulation, the other is a prediction. How we do that is we take cities like Vienna, for example. We produce 3D models, we run thousands of simulations, and we use these simulations to train sort of like the neural networks that predict the simulation results. And we've done this for heat, wind, solar radiation, and comfort. For now, the platform is out to use. I mean, I'm just quickly skimming through some versions of it. It's really literally as simple as like, putting a building there, moving it around, and clicking a button and getting a simulation instantly done. So you can, put form in and then immediately know what the effect will be on the climate. And you can do things like, for example, putting a park in a sort of like urban environment, and then figure out the effect it will have on the wind instantly. So you see like, I'm moving the park around, and instantly generates new geometry, instantly generates the sort of like wind comfort map, etc. I'm going to skip through that. This is the platform now. We just released actually the sort of like commercial version. So if you want to try it, come talk to me afterwards. We have an open demo. And then of course, how do we use that in projects? I'm going to go very quickly through this example of how we used infrared with Link in an actual project in a sort of like urban redevelopment in Norway. You have like essentially the idea of the quick massing, just generating form, putting in some parameters, and just very quickly populating form. And every time you change something, you generate a simulation. As I said, you can move parks around, immediately get wind comfort results. But it's not just about wind comfort, it's also about how many people have access to the park. So when you move the park around, you also immediately figure out what parts of these sort of like master plan can have access to this park, and how quickly will they get there, how many parks do you need to actually serve everybody. Transportation, like planning essentially transport line and figuring out catchment areas, or where people will walk exactly, how many are exposed to noise, etc. And I'm gonna probably come close to finishing here. I don't know how much do we have. Like we have 5 more minutes or so. It's okay. So this project is essentially about generating 1,000 different solutions for a certain sort of like for a certain master plan. So you have like you set certain parameters, you generate 1,000 different potential solutions, and then you bring them into the table of the negotiation, and you can continue playing with it. There's a bit of augmented reality aspect here, so you can actually see the design in front of you on the table, and you can manipulate it. And every time you do something, your sort of like action, your design decision is automatically assessed with all of these tools. And you can also use the machine to query things. Like for example, you say, I want this tower, I know this design is performing well, and I want this tower, and the machine can figure out where the tower exactly should be so that it minimizes wind sort of like issues, etc. So this dialogue between the human and the machine is all that this is about, and I think that's sort of like the main message I'd like to give here, which is the idea of using sort of like AI more as an assistant, which is what the norm is today, where this is going, rather than as considering AI sort of like replicating the creativity of the architect. So all of these sort of like videos relate to this idea of assisted or augmented modeling, and essentially this was what we did in Dubai in the World Expo. So you can have like a whole environment around you, physics environment and simulation environment. You can play with form and immediately get answers as to sort of like how the form is performing. And finally, I'm going to touch upon imagination, and that's probably the last thing I can, if I have the time, to to talk about. And of course, you know, we have seen this. This is the mid-journey sort of like stuff that everybody was trying to avoid. There was even sort of like, you know, hate posts about it. But this idea of imagination with, you know, using AI to imagine things is not completely useless, or I hope so it isn't. This is my other co-founder's sort of work, where essentially you have like, you know, a prompt. This was done actually before Midjourney. That's kind of like what's cool about it, where you could just like type, you know, a house with 2 bedrooms, etc., and it would just generate a floor plan immediately for you, and not just a floor plan that's also analyzed in terms of its daylight availability, its sort of like, you know, connectivity, etc., etc. So it actually has a lot of merit. Of course, you can do things like, you know, another student project, you know, replace your floor with some new floor, and, you know, figuring out how your new furniture will fit in your house. But it's also things that you can do is like, you know, look at a public space and figuring out just with a few prompts how things will look like if you replace, you know, this is just like this space, and you put a couple of keywords: standing desks, co-working space, green, etc., and it just populates things like that. And again, project done in less than a month with no AI knowledge before. So this sort of thing. And I think for me, my most favorite project is that, a tree hopper, which we won a hackathon with, which is essentially, oops, we're gonna have to shut it up. Wait, sorry. How do I lower the volume? Thank you, bye. So yeah, like it's essentially a participatory project where you get like the citizens to figure out where to plant trees, because city of Vienna wants to plant 25,000 trees, and they want to figure out where. So the citizens essentially put a tree anywhere they want, but every time they put the tree, they see the effect the tree will have on the specific environment. So in terms of microclimate, using infrared, but also in terms of like how, you know, how feasible it is to put that tree in that location, and that helps the city then identify where people want the trees to be, but also citizens being, you know, educated on what the effect of the trees would be in the microclimate, so they don't just put the trees on top of their car parking spots. So yeah, finally, AI again. Just closing with this. Has anybody heard about the Turing test? Right? Probably have heard about it if you're an AI enthusiast. It's where you ask, like, you're behind a wall and you ask a machine and a human a couple of questions, and the machine and the human, you cannot figure out which one is what, right? Like if it's the machine that's answering or the human, then you've passed the Turing test of, you know, intelligence, demonstrating intelligence. And I think ChatGPT, at least in its 4 or whatever version, has passed the Turing test with high flying colors or whatever. But then there's the answer, to the sort of like thought-provoking answer of like the sort of like Alan Turing test, which is the Chinese room, which is like the case of someone having an infinite amount of sort of like input-output Chinese characters, but knowing nothing about Chinese. And when they get sort of like a set of, a question, they can give an answer, but they don't understand anything about what they just said. And they don't actually have any intelligence, but they can fool you that they know what they're talking about, which is exactly what we're having, as a problem with AI now. You're writing a prompt, and what you're getting is essentially consumed knowledge, knowledge that already exists, and it's just spat out to you in a sort of different configuration. It's nothing new. The machine doesn't really think or really create new knowledge. It just recreates the knowledge that you have. I think what is more useful than the sort of like imagination of ChatGPT is RAG models and knowledge-based models that actually give you referenced results rather than that. But in the end, it's all about how we combine machines and humans. I think the quote here, which I don't know who it is from, but I stole it from Reinhard Koenig, who was running the lab before me, is that computers are super fast, accurate, and stupid. Humans are very slow, inaccurate, but very creative and brilliant. So the combination of the two can be a force beyond calculation. And on that, I'll shut up because I think I spoke too much. Thank you very much. Join us if you want. Almost.
Thank you. It was very interesting. Like, we could see that AI is not really about generating of images, but there are many ways how we can use it one will be Jan Parnecký, and I'm curious about this presentation because I really don't know what will be about. So we will see. We will not have too much time for discussion, but it doesn't matter. There will be.
I'll be brief.
Dancing session.
Could I put these here so that I'm
discussion. So we have to finish until 8, but I think we will manage it.
Yeah, I'll make it brief.
But your presentation was so interesting.
Okay. So I'll use this computer. I just need to type a link here. If this is connected, it does. Okay. Yeah. I'll just do it here. Sorry for the delay.
So probably if there are any questions from the audience, you can ask now. Probably to use the line. Just one question.
Good evening. Thank you very much for a nice presentation. I just would like to ask, we have seen very nice examples from Vienna. And I just ask you, are those software interfaces customized specially for Vienna, or is it possible to replicate it to different towns if a different town will ask, for example, all those applications for trees and all those things? I mean, how easy it is actually to apply it to different town if different town will ask for it?
Yeah, maybe I'll respond to that. I'm not sure if this is okay. It's global. The models are global, and Vienna is mainly because the City Intelligence Lab is in Vienna. We have to show often things to politicians as well, so we have to make sure we use the right city. But no, it's global. The models are global. You can apply the same sort of, for example, the same workflows in any city. We mostly work outside of Vienna.
Thank you very much.
All right. Okay, thank you very much. Thank you for having me. Actually, it was in this very space where I had my first public speech or lecture or presentation 15 years ago. You were here as well. And I wanted to say that so many things have changed since that time because I was having a lecture about dinosaurs. And actually not that much has changed because the point of that lecture was exactly the same as what I'm going to show now. In the meantime, me being an architect, I wouldn't say that I'm a failed architect because I never even tried. So yeah, that we would never know. But in those 15 years, I was promoting the computational design, the use of computers for creating architecture. I was teaching, and I also had a studio where we were applying the parametric and computational design in designing objects, not really architecture. And we slowly shifted towards creating tools for architects and software. Currently, I'm here on behalf of a brand called Cubu, which is a software company where I'm part of. And I would like to show you very briefly what we are working on. And I think it's super related to what you are doing, so I was very happy to see your presentation. And what I'm showing you right here is a very shortened version of the company presentation that is usually not meant for architects. And this is going to be slightly different. And for me, it's a strange situation because I'm showing something that is related to architecture, but not meant for architects. And I usually talk to architects about architecture in the past. So what we are building here at Cubu is a software tool that enables designing residential buildings end to end. So you start from nothing and you end up with a project of a residential building. What we care about is accuracy and ease of use. The accuracy is fine, the ease of use is not that fine quite yet, and we are still in the process of development. And we've got some basic pillars on which we build. I will just mention some of them. One of them is that we have that we are generating a multitude of options where from which the architect or the planner can choose the most suitable one, but we are also evaluating those options and basically sorting them according to their viability in that specific project. We also care about the precision and accuracy. I will mention that later on. And the whole principle is based on the discrete assembly approach, where we take rigid pieces of space and assemble them together in a meaningful way. This is something that is based on our previous project that somehow reflected in this one. You might have known, might have used a tool called Monoceros, which was a wave function collapse implementation for Grasshopper, something where you designed your modules and those modules would be assembled together according to certain assembly rules. So basically this is something that we show to developers, to real estate developers, and we try to convince them, and we are also convinced that that the usual design process takes long, and there are actually drops in performance because in between of the stages you go from tool to tool, and the accuracy drops, and you need to redraw things and send files back and forth. Instead, what we are doing is that we are designing the full, like covering the whole design pipeline within our processes. But that's but this is probably something that might be a little bit more interesting here. So we are collecting all the information that we have. This, yeah, it's an animation. So we are collecting all the information that we possibly can have about the site and about the project into something that we call an informed space, which is a common way of storing space-related information. So if you imagine that any point in space, you can request that point, and you get the information about everything that we know about the space. So, for example, how much noise there is, or what it contains, what is the potential, what is allowed to be built there, what is currently built there, what is forbidden to be built there, and so on. We put these information together, and that's an input for the next stages. Yeah, so yeah, that's the informed space. So you can imagine it as a multi-layered spatial map of certain values that are distributed, scattered around the site, and with that could be an input or way how to look at your design project when you are in the process. So when we have that, we can start producing something that we call urban blobs, or basically some sorts of envelopes where the buildings actually can be proposed later on. It's somehow similar to your solar envelopes, but these ones are optimized towards a multitude of targets. So basically, this is a multi-objective optimization. In this case, it's about 20-25 currently, but we are working on more. So we are optimizing a lot of things at the same time. So, for example, the built area that these buildings takes, the gross built area, so all the floors together. We are measuring the daylighting, direct sunlight daylight factor, so difficult daylighting we do there. also distancing between the individual buildings. And we are taking into consideration other things, like, for example, soft inputs, for example, the anticipations or wishes of different stakeholders. Somebody wants to build in certain part of the site and not in the other one, so we put certain priorities and weights in certain aspects. At a certain point, I should start talking about the AI, right? So the thing is that everybody wants to hear that we are using AI, and technically we are. But to be very specific, this is not the AI that you have in the GPT or Mid-Journey. So there is no large language model, there is no diffusion model, there is not even a GAN network. So what we do is we basically are developing search algorithms that are super accurate, but they are still learning from themselves, and they're finding the solution over time easier and easier. But this is not a neural network, not quite yet. Instead, but still technically, it's an artificial intelligence when it comes to the computer science. This is quite important also for us because with our approach, we can claim that analytically the solution that we found is the best of all possible solutions according to the targets that the user anticipates. Rather than if we were using neural networks, we would have to include some additional evaluations. But we made sure that the processes that we have are fast enough so that we can have the full accuracy all the time. This is also dependent on the data that we put in the Chinese room. That applies to us as well. The better data you provide, the better data you get, which is something that it's about the level of detail, because this is also based on the assembly process where very small pieces of buildings are being put together in a meaningful way. It's also super important to have correct data on the input so that we have correct data and detailed data on the output. But as long as it's possible, we work in something that we called low fidelity. So a model of a building that is super simplified when it comes to its spatial distribution and spatial annotation. What you see here is a lower resolution picture for some reason. It will probably get better soon. But it's also a low resolution version. Yeah, it got better. It's a low resolution version of that building, and it's chopped into smaller pieces that we call fragments. Those fragments, they're the small pieces of building that contain certain annotated information about that building. This floor of an existing residential building, it consists of not that many fragments like this, actually. You can see the whole collection of them here. I think in this project it was less than 50 different pieces that you can assemble together and create all versions of this building out of these. Then when we finish the low fidelity optimizations and searches, we materialize the solution into something that is a realistic building that already has all the information, all the data that you need to have when you want to build a project. So basically we go into the full level of detail. I just added these slides 5 minutes ago from a different presentation because the solution also consists of very deep analytic models. For example, we have one for daylighting. We are not using AI for daylighting, but we have optimized the analytic solution so that it's not precisely instant, but it's almost instant. So it takes very few seconds to actually compute daylighting for even a large residential project. And this is super important because the speed of the solution allows us to include it into the design process. So, and I believe that was your call as well. Instead of designing something and then checking whether it complies with energy and solar requirements, we optimize the design towards the daylighting goals. And this is one of many targets that we have when we are proposing a building. So many times they are contradictory. The potentials or intentions are contradictory, and they are somehow fighting with each other. But eventually, it finds a balanced spot where the building is so optimized for all of those targets, and sometimes it's sometimes the result is not exactly what you would expect. Therefore, you can set a higher weight or importance of certain aspects of the optimization. That's another daylighting picture that comes from our software. This is about the tech stack that we have, the optimizations, implementations, and so on. Just so that you know in which stage we are, whether I'm just showing you some pictures and making things up or not. Most of the things that you have seen in this presentation comes directly from our software. We had a previous presentation with even more pictures from the actual process, and that contained like 100% outputs from our software. The thing is that it's now available as plugins for Grasshopper. That's the platform that we've seen here in basically every presentation. This is because we need to test this approach on actual real-life projects, and this is actually what we do. This is some sort of a timeline that we have. So we are developing an ultimate software solution that we call a studio, which takes some time. We already have that on my other computer. I wanted to demo the actual software to you, but never mind. But meanwhile, we've got the integrations to the existing industry standard software, so that the computational designers, they can put together their own generative pipeline and test the individual steps and evaluation steps for creating a residential project. But mainly, this is something that we are doing in-house with the pilot partners, and we are basically designing buildings and testing our approach on that. And that's basically it. Thank you very much.
Okay, thank you. We have, let's say, 15 minutes for discussion. I have just one, on one hand, simple, but on the other hand, quite difficult question. What do you think, or how do you see the role of architect in the future? I mean, like, that's also something what Neil Leach is talking about in the interview in Era 21 magazine, because it was assumed that the factory workers will be replaced by AI, but now seems that the so-called white-collar workers will be replaced by AI, like doctors, lawyers, engineers, computer scientists, and also architects. So my question is, if you are afraid that the AI will replace us, will replace our profession, or not, and how quick this change will be, and how AI will change our profession in the future. Who want to start?
It's an easy question, right?
I know that's quite a general question, but
I guess I was the one talking to Neil Leach, so about this. So maybe I'll start. I think the reason right now we are worried about white-collar jobs more than blue-collar jobs is A, because white-collar people are louder and nobody hears the complaints of blue-collar workers. B, they not even AI is willing to work for the money blue-collar workers earn, or in other hands, developing AI which would replace high-paid jobs makes more sense financially. Regarding architecture, I don't think we are, although it looks like Jan is working on it, but we're probably not there yet. But I personally feel that it's much more because of legislative and sort of social network of our society than because of technological things. We see in automotive industry and so on, integration of different techniques much faster than in other industries. Not because cars are somehow different, but because the industry is new, therefore it was able to adapt faster. Now I'm not talking about AI, I'm talking about, for example, robotics. And I think architecture or construction, let's talk about construction, is all the industry which doesn't include only like drawing houses and building houses, but also allowing houses to be built, all the legislation, all the bureaucracy and so on. And it's a big part of our society as a whole. For that reason, I think it's not immediately the issue.
I disagree with Neil in principle. No, I think that I don't remember a time when I was doing something that, like, you know, I was not questioned about, you know, oh, what is the role of the architect now? When I was doing parametric design, people would say, okay, now what is the architect doing? You know, parametric design is going to take over. And I've been hoping for the moment that he's going to take over for the past 15 years. It's never happened, unfortunately. You know, because I'd like AI to take over larger parts of my job because I don't like doing it. But you know, at the same time, I have zero conviction that this will ever be the case. The human mind is conditioned to innovate. The human mind created AI because it's conditioned to create, to innovate, to be creative, to break barriers. So there's no way, no technology we can put to the human mind that it will actually stop its creativity, its innovation. It will just find other ways to express itself, hopefully not with Mid-Journey and imaginary sort of like soups of forms, but you know, with better processes. I feel more that we don't have a responsibility as architects of what we're doing than, you know, of sort of like the climate conditions we're creating, of how we break the planetary barriers without caring about them, than I fear that AI will take our jobs or something like that. I don't believe that the technology will have the impact on white collars, blue collars. It's the financial models that we follow. It's neoliberalism that takes jobs. It's not AI. I'm sorry to say that bluntly, but that's the reality. Like, you know, it's how we use AI. And you know, people now talk a lot about sort of like the impact of AI on sort of like you know, the energy sort of like impact of AI, because you know, every time we kind of like post that kind of like prompt to ChatGPT, there's a server running in the back and all of that, and now people start talking about it. We don't even see the impact, right? We don't actually understand the impact. And as architects, we design and we build buildings with zero responsibility for hundreds of years. And I think for me, one of the things that this can bring back is actually, you know, show us the responsibility. That's why we're working on, you know, the impact that your design has. Simply put, like, you know, I was looking for a new flat like a couple of years ago in Vienna, and I figured out a nice new flat with a, you know, view to the river. And then I looked at noise levels, and you know, like just 10 decibels more of noise kill you 10 years like younger than if you don't have that noise exposure. So what do we do in terms of like, you know, how do we actually affect our own lives? This is more important to me than whether AI will consume our creativity. I think we just need to channel that creativity to the right cause. That's my only suggestion.
Like, I can have a serious answer and, or a less serious answer. I don't know. The thing is that, so if there is a chance to design buildings based on evidence, why wouldn't we do that? So we need to go into a complexity that is difficult to handle by people, because if there is a possibility to design a house where the noise level is 10 decibels lower, or the climate impact is the carbon footprint is lower, you need to have a tool that actually tells you that, or even better, optimizes your design towards that goal. So yeah, if that means that it takes jobs from architects, then yeah, probably, but for a better reason. And then there are many other answers, like, for example, there will still be architects who are avant-garde, who will be creative, who will go beyond the borders, just like there will be architects or basically any other profession that will do whatever they get paid for, and this is something that we are doing. This is something that we are trying to take those, the level of architecture that is being just produced in quantities, and we try to make it better, to base it on evidence and on optimizations that make sense. We are never, like, what we are doing is never going to be that creative.
Are there any questions from the audience? Or you can also ask each other if you want.
I have a question to you.
To me?
Yeah, was it wave function collapse or reinforcement learning?
None of those. More of a wave function collapse. Yeah, the discrete assembly is based on wave function collapse, but we also have a lot of simulated annealing and genetic algorithms and this sort of multi-objective searches.
Sorry, I have this question from before.
Well, I think it was
Exhausting.
it was many interesting informations today. So probably we have enough. I don't know. Is there any question or not? Don't be afraid.
You have the last chance to give a question.
The last question, because we have.
I'm just wondering what you think about AI and creativity. If AI is creative, because later and later I haven't seen any surprising image, any surprising solution by AI. So that's my losing trust or belief or what do you think about creativity and AI?
I'd like to pick that because I think I kind of like try to talk about it before, but maybe not in the right terms. I know AI is generative. I don't think it's creative. It can generate things that we have never seen, right? New faces that we have never seen. But the creative part is still ours. And I think that's what you see also, like the models that come out that are fed with, we don't know exactly what AI does. Two examples, right? We know that, for example, translation AI models that do translation, when they were presented with, like they were learning English to German and then German to Chinese, but then when they were trying to do English to Chinese, which they hadn't seen before, they would create an extra language, which we have no clue about, like we don't understand. And they would just create a middle language to deal with the translation. That's like a generative component. It's not a creative component. If we then go in and start visualizing that new language, and then we create something, and we create a new language because we like it, that's sort of like, it's our creativity. Another example, the typical test of figuring out if AI is going a little bit like, out of control, is that they're trying to see if it can do certain tasks, like, for example, try to steal money or whatever, or if it can pass the CAPTCHA. You know this thing that when you go to every website they ask you to like click on something? It has nothing to do with what you click, it has to do with how you move your mouse. So the way you move your mouse, the model understands that, that it can essentially, it's a human. So AI cannot pass that. But what, they put like a bunch of like LLMs, 8 LLM agents to work with each other, and what they try to do is hire someone that presses the CAPTCHA for the AI. So like they posted a job on Fiverr or whatever, like, for someone to go and sort of like press the, so AI can be created in the sense that it can generate solutions, but it will not create new ideas as far as I'm concerned. At least for now, right? Eventually it might do, but I don't think it does actually. It helps us create new ideas. That's why I call it augmented intelligence rather than artificial.
But now, later? There's a chance.
It will depend on when we will have the Third World War. But I'm not sure. I don't know. I have no clue.
If I may, I agree that the images, they are never really surprising, but at the same time they are not lame. Like at least Midjourney has quite a good taste. So if when the internet is, well, but just compare. So the social media is flooded now with Midjourney images, in comparison with what was there before. This is a higher quality visual content. So at least for me, it sets certain standards to the visual content, which is not so bad.
Yeah. Like for me, if I take very different topics together, I mean, it's blending, maybe generating something new, and if you go deeper, you understand, okay, this is this family, this is this family. But somehow I really like the process from the noise with the patterns. It's trying to get something very different. And from some examples, I was surprised with my results.
So you get inspired by the results.
Have you developed any surprising solution like Kubu? No.
Yeah, it's a photo book. It's based. It's this picture, egg or chicken. If you have just results, or you will get the result.
It's surprising how many options you can get. But still under the limit.
Yeah. No, I said no immediately because that's not even an intention. Because we are optimizing the algorithms actually to bring results that are expected. So we would kill the surprises in the development phase.
Who ask you for unexpected?
Yeah, that never happens. That would be very unexpected. But not if you're targeting developers. But sometimes it creates. So when we are in the very first stages, in the urban stages, when where we're creating the urban envelopes, the blobs, very often they are surprising, or they definitely are something that human would not design, in a good sense. So they are more complex. They have certain weird moments. But when you think about the reasons why this happened, this is fully deterministic. We know exactly why that solution was chosen. So if you think about it, you will realize why this is happening. So in the urban scale, it happens. But then for us, it's not good news because we then need to proceed with the more usual. So the very unexpected solutions, we don't continue with those. But we allow the user to stop there and continue manually from there on, or for a while, and then use our creative pipeline later on for example, distributing apartments that you might not be interested in doing. So you just create some crazy envelope, or it is created for you. Then manually you tweak it a little, and then you just let the computer to distribute the apartments into the envelope. That's possible.
I want to just add one reference that may be interesting. Son Hanna, professor at UCL Bartlett, papers about 2009, 2010, that architecture problems, he was talking about optimization, right? He was talking about sort of computational design optimization. Architectural problems are always wicked problems. Wicked problems, there's a specific definition of problems that cannot be optimized because they have too many parameters that are always conflicting or sort of impossible to find. There is no landscape where you can find the sort of global optimum, because architecture is by definition a problem. Like when you get a site and you want to have to build something there, there's a multitude of parallel universes where solutions can be optimal and perfectly sort of optimized or globally optimal for the intention that you put in. So there, by definition, a wicked problem. There's no way we can create the solver that solves the architectural problem. What we can do is make things a lot faster, a lot easier, a lot more accessible. So instead of you having to draw lines on a stupid, screen with, a mouse. What is a mouse? At the end of the day, you know, it was presented to Xerox, they were laughing about it. So, you know, instead of like having to get a tendonitis by, you know, clicking things, you can actually just say, you know, what you want to see, what you want to test, but you still test it. You still sort of like, you are the hopefully half-educated human mind that knows a little bit about the problem. I doubt that, you know, as an architect you have the full overview of that, but that's another discussion for another day.
Okay, so I think we have to finish for now, but we can continue, of course, in the pub, for example, with our discussions. So thank you very much for your attention. Thanks to Jan, Jiří, Shota, and Angelos for coming and
Yeah, and thank you on behalf of the Foundation of Czech Architecture, and I would also like to all the speakers for the great presentations, and to Filip Landa from Era 21 for creating this wonderful panel. And I would like also thank you for discussion, for questions, and I would like to invite you to our next event within 2 weeks. We will be having here an evening dedicated to Black Box or Black Cube, Černá kostka, the library in Ostrava, and I think it will be also interesting. So follow us on our social media. So thank you very much, everybody.